Okay, we're at the point in the notes where we have a graph, and that's figure 1, page 3. Let me go to that. And we're looking at this over here, and then the question is, how do you generate that graph? And so I'm going to go through that with you. I'm using an application called Grapher to do that. So the first thing I want to do is I want to graph the solution to the problem, and then we'll graph that slope field. All right, so the solution, let me go to Grapher. And again, you can use the applications you want. Don't think you have to use Grapher. All right. Now, certainly I typed in some things already. I'll turn them off, but I'll go about how to type that in. So the first thing is that I want to type in this solution. And again, going back to the original problem, that solution I said was y equals the sine of x times cosine x minus cosine x. Well, I'm just going to type it in for you, show what it looks like to type that in. And we'll talk about the restrictions and stuff like that too. So, you type in, y equals, pretty easy to do. And that's going to be sine of x, right? And again, that's the solution right over here, times the cosine of x. And then it's going to be minus cosine of x. Oops, I didn't type in cosine, did I? SOS. No, it's cosine. Right? Now, what I'm going to do is I'm going to change the color of the graph to red. I'm using the inspector. And I'm going to do color. I'm going to make it red. Right? Got that covered. Right? The next thing I want to do is I want to change the viewing window. Because remember we said the solution is valid between minus pi over 2 and pi over 2. All right? So, pi over 2, roughly 1.5. So I'm just going to make the window from minus 2 to 2. All right? So let me change the axis and grid to that. And let's take a look at that. So axis and grid. And I'm going to change the abscissa to minus 2. Oops, I'm sorry, up here. Minus 2 to 2. And the scale is going to be, units, 1 unit at a time. All right, so I got that graph over there. All right. Now I'm also going to graph in 2 more lines. I'm going to say new equation. And I want to type in that x equals pi over 2. All right, I'm going to change that appearance of that. And the other line I'm going to type in is going to be x equals minus pi over 2. The way I type pi, I just typed in pi. Right, I want to change the appearance of that, and I want to make them dash lines. So inspector. I'm going to change a line, and the appearance I want is a dash line. All right. So again, someone's going to say, what are you going to do now? I need to type in that, I'm going to call it a vector field, because it's plotting little tiny vectors out, and those vectors have slope. They also have a length to it. And someone says, what are the vector fields going to be? It's going to be that direction field of these derivatives over here. All right. So I want to go back to what that original differential equation looked like. And the original differential equation, if you recall, looked like this thing over here. Right? The derivative of y with respect to x is equal y, a function of x, times the tangent of x equals cosine squared. So I want to go back to Grapher, and I want to show you what that direction field, and I will type it in for you, I'll show where it is. But right now the direction field is over here. And I want to point out what it is. It's sort of like, over here is an operator, and this looks like to me it looks like a matrix, x, and it says, the derivative of x with respect to x is 1. Right, that's a given. The derivative of y with respect to x is going to be something else. And what is that going to be? Well, if I looked at it, let me click on this over here. What would it be? It would be the cosine squared. I just typed it in, and I'll show you to type that in a moment, minus y times the tangent of x. Let me explicitly put the multiplication symbol in. I'm going to select this thing. It's going to draw it out for me. All right. Now, granted, someone says really busy, and looking at it, I want to point out, select it now, And what I want to do is I just want to, select all the graphs now. I'm going to select Command All, right? And what am I seeing over there? I'm seeing a pretty good picture now. Now, someone can say, could you zoom into certain regions? I can. And certainly, something, special things are happening at minus pi and pi over 2. And you may wonder what those are. And the reason for that is the tangent function is not defined at that. All right, you need some, get minus pi over 2 and pi over 2 not defined. That's why we restrict it between those two numbers. And you could restrict it to other numbers, but that's why we restricted it between minus pi over 2 and pi over 2. And again, looking at this, I want to point out, just looking at the red curve, right, which we said was a solution, it's going through the direction field. If you see that, if you look at this thing, it's actually following those arrows. It's actually following the arrows. Now, so how would you type that in? I'm going to turn it off. And what I want to do is I want to insert a new equation. So I'm going to go down here, just like I did before, and I'm going to take one from a template. And what I want to do, there's different, parametric differential equations. You see that over there. They're pretty interesting things, but I'm going to just do the vector field. All right? And the vector field I'm going to do is explicit Cartesian. And say, okay. And it gives me sort of like this template form. And again, the derivative of x with respect to x is 1. Let me go back to my original differential equation. This is the derivative of y with respect to x. What is it equal to? Well, this is going to be the y component. This is the derivative of y. That's going to be cosine. I'm going to type in a square now. And then it's going to be, the argument's going to be x. Then what I'm going to do, it's going to be minus y times the tangent of x. And let me hit return, and we get it back, all right? Now, I also want to go to this inspector over here and show you have pretty good control over this, right? Pretty good control. For example, the line's got little arrows on it, and they're actually pointing in the direction, all right? But I'm not too worried about that. So what I'm going to do is I'm going to change those things to just, regular lines. Let me show you what that looks like. And right now, what do I have? I got rid of the arrows, all right? You notice I got rid of all the arrows on that. All right, let me go back to this. You notice when I selected, it's actually telling me I selected that, all right? I'm going to go back to inspector. And what I'm going to do now is, change the density of it. So I'm going to go low density on it. I'm going to refresh it. This little refresh button over here. And you notice I got less busyness. Now, someone says, could you get really busy with that? I could. I could do high density. Right, now that's a little bit too busy for me. So I'm going to back away. Again, each time I do that, I need to refresh it. All right? And again, you could play around with the vector size. Let me show what I mean by that. I think you get an idea. I can play around with that. And for the most part, I would play around with it. All right, you can play around with colors and things like that. But the bottom line, feel comfortable with what we're doing. All right, and feel comfortable with that. That doesn't mean you're comfortable using Grapher. What I'm saying is be comfortable creating a direction field and a solution that goes through that direction field. Right, get comfortable with that. Again, a lot of teachers are going to say, oh, do this by hand. I just find this incredibly tedious to do by hand, by the way. And I'm not really good at graphing, so I'm going to use a machine for it. And we should really start to depend on machines to do things. This is a good example of that. So let me go back to my original picture. Let me get rid of this. Get back this one back over here. And I'm going to select all the graphs now. That's Command All. Whoops, sorry about that. Let me get rid of this over here. You know what I'm going to do? I notice I have arrows in it. I'm going to get rid of those arrows. I didn't know that, see that before, actually. And you know what I'm going to do? I'm going to refine those, the lengths of those things. All right. So vector size. Let's just pull it down a little bit, a notch or so. See what I'm doing over here? Make them big and small. Let me make it like a reasonable size. I'm going to say like something like that. All right. Let me close this out. Let me select all again. And again, I'm getting a picture. I want to go back to the picture that you were giving in the notes, by the way. Let me pull this on the side. And really, I'm getting the same exact picture, by the way. Now, someone could say, how would you like save this picture? There's many ways of saving it. I would say a typical way of saving this is just, export it, right? Export it as some file format. And typically what I do is I save it as a PDF, all right? That's what I normally do. But you have choices over here, and there's plenty of them: TIFF, PDF, encapsulated PostScript, and JPEG, right? You could also save the file as a Grapher application file if you want, or Grapher format, whatever you want to do, right? Learn to use software. I'm showing you Grapher. I like to use Grapher, by the way. Sage works well. All kinds of software works well, including web-based applications. Thank you.